Hello and welcome to another WJEC A level physics question. This is Unit 1 May 2010 and it was the first question on the paper, and it's a basic vectors and scalars type question. The first part of the question asks us to state the difference between vector and scalar quantities. Well, we should know that vectors have size and direction, whereas scalars only have a size. So we could simply here say that vectors have direction, scalars don't, because you're just asking for the difference. Of course, a full answer like vectors have size and direction, scalars don't is also perfectly acceptable. Next thing we've got to do is sort a list of quantities into the correct columns of vectors or scalars. Distance is a scalar. The vector equivalent to that is displacement. Time is also a scalar. Velocity is a vector. Temperature is a scalar. Force is a vector. And density is also a scalar. So easy enough. Now, in the next part of the question, we have a horse pulling a boat along a canal, and he's pulling it via a rope, and this rope is making an angle of 25 degrees to the sort of forward direction there. So what we've got to do on the first part of the question is calculate the forward component of that force if the tension in the rope is 1600 newtons. So let's call it F. So it's 1600. Now lots of people get confused about whether or not to use sine or cos when they're trying to resolve a vector into a particular direction. But a simple rule to remember is that if we have the angle between the force, so over here we have that force of 1600 newtons, if we have the angle between that force and the direction that we want, which is this forward direction, we always use cos. So it's going to be 1600 cos 25. Putting that into the calculator will give us an answer of about 1450 newtons. The last part of the question says, ignoring the effects of the mass of the rope, explain whether it's better to use a long rope or a short rope to pull the boat. Well, what we want ideally is for most of the force to be in the forward direction and very little of it being in the sideways direction. So what we need here is to make the angle as small as possible. And if we make the angle as small as possible, that means our rope must therefore be longer. So the simple answer is that we need a longer rope. And then the explanation is that this gives a smaller angle. And therefore a greater forward component. So thank you for listening. Please remember to like and subscribe.